Hello class, welcome. Today's an exciting day of basic trigonometry 101 that you are going to be using here in physics. Oh my goodness, geometry and physics together, mind-blowing. Yes, you know those pictures you're working on with the force diagram that look like this? Ooh, what's it gonna be? Yeah, and it was like F of N and F of G. And then we have like over here like an F of a, I don't know, you're Poland, so F of T, tension, right? You're going to be using that stuff and what we're learning today all wrapped up into one. Awesome. All right, parts of a right triangle that you must know. You need to know that if you're looking at it and you're saying angle A, right, and you're looking at it from angle A, then you have what's called an opposite side, an adjacent side, and a hypotenuse. Your hypotenuse, no matter what kind of a triangle it is, it's always going to be directly across the right angle. By the way, trigonometry is only done with right triangles. We can't do it with any type of other triangles. Not an equilateral triangle, not a triangle that has like an angle of 60, 70, and 50. It has to have a 90-degree angle. And then there's also an adjacent side, so that sucker's right next to your angle that you're referring to, or there's called an opposite side, which is directly across from your angle. So sometimes if you cover up your angle, it's the side that's not touching your angle. And then there's this thing that happens where you might be talking about the other angle. So if you're talking about the other angle, what do you think is going to happen to your adjacent and your opposite side? Ding, ding, ding. Did you say, oh, Ms. Bravo, they're going to switch sides? If you did, you're a genius, because they are. You will never be doing SOHCAHTOA and refer to the right angle C. You're always going to be using sine or cosine on either A or B. Okay? All right, so let's review. So if I'm here and I'm saying, hey, label my adjacent side or point to the screen, which one's the adjacent? Did you say down below is my adjacent and across is my opposite? Genius. Now what's going to happen if I have a triangle and I move the angle that I'm talking about? So for angle B, the opposite side now becomes, boom, down below. Again, if you were to cover up that angle, it's the side that you're not touching. Hypotenuse never changes. All right, so now we got these things called a trig ratio, right? And a trig ratio is you're just comparing the lengths of all the sides. And there's 3 different ways you can compare. You can say opposite over hypotenuse, adjacent over hypotenuse, or you could say opposite over adjacent. So if I do opposite over adjacent, and I'm referring to my A side, if I switch, I'm going to refer to my B side. So remember that story I just told you, Chief SOHCAHTOA? Booyah. If it was me, I'd say, yo, I'm going to time out, and I'm going to pause it, and I'm going to write it. But that looks like a lot to write. So let's not write all of that. Let's abbreviate. So it's not sin, it's sine of A equals, and you can abbreviate it just like this. Oh, you mean we can really do that? Yes, we can really do that. Isn't that just amazing, people? I'm going to just abbreviate just like that. All right, and then continue. So just remember, if you're doing sine, cosine, or tangent, that if you use that cool thing that we just did, SOHCAHTOA, it's going to make life a whole lot easier. So the first part of your homework, boom, where's it at? Right here. Remember, we need these because Ms. Nash is going to come back and we're going to do vectors, and it's going to work out beautiful. So if I'm doing examples of trig and I want to know, hey, what's the sine, cosine, and tangent of angle P? Well, I can remember SOHCAHTOA because of that awesome story we just learned, and I can say sine of P equals opposite over hypotenuse. That would be 16 over 20. Ooh, that was not written very well. I am sorry. Let me try it again. Cosine of P equals adjacent over hypotenuse. So that would be 12 over 20. And last but not least, we have tangent of angle P, and that's going to be my opposite, 16 over 12. And you're like, Ms. Bravo, this is nuts. You're not even reducing. Do you need to reduce? No, don't waste your time. You know why? It's going to give you the same answer, and we just don't have time for it. It's not going to change your answers at all. That's for problems 1 through 6. So if you're like, oh, my brain hurts and I need a break, then feel free to pause this video and continue on with 1 through 6. Now the next part of this video and the last part of this video is going to be finding the angle measures of these trig ratios. Alrighty. So if you're with me and you need a calculator, pause it, go get a calc. Hot dog, we just got a calculator. Look at that. Woo. Now if you're thinking, Ms. Bradford, I have this awesome phone that's cool, but it doesn't have all the wonderful trigonometry functions that a standard T30 is going to give you. So please get one of these. All right, evaluate sine of 40. This is mind-blowing. Are you ready? The sine, cosine, and tangent buttons are on the second row above the 7, 8, and 9. Literally, you're going to click on sine. Oh, first on. You're going to click on sine 40 equals. And you're going to get a long decimal. Oh, did you get that decimal? You mean that's all we have to do for this part? Yes, it's fabulous. So we're also going to be giving questions like sine of 55. Plug that sucker in. Sine 55, sine 10, sine 87. What you're doing is you're finding those fractions that we just did and you're dividing them out, and that's what they would have gotten. We're just doing a little shortcut for it. There's this thing called the inverse, and this is the part you need for the bottom of your first worksheet, numbers 1 through 8.
Sure.
Thank you. So on the inverse of it, if you were to looking for your angle, and let's say this is your original problem, right? Let's back up and do Math 101. If I had 2x equals 4, and I wanted to know what x is, you would say, oh, Ms. Bravo, the opposite of multiplying is to divide, so we're going to divide everything, and that's going to give me my x equals 2. Or if I had x plus 4 equals 9 and I wanted to solve for x, well, the opposite of adding is subtracting, so I'm going to subtract x equals 5. Well, what's the opposite of multiplying your beta? It's using your inverse. How do you use your inverse? That's a very good question. If you go second and then hit your sign button and then type in that decimal 0.7315, push equals, that's going to give you what your beta would be of 47. If you want to check your work, type in sine of 47 and you're going to get that decimal. Mind blowing. All right, that's what the last part of that first side of your worksheet is going to be. If you're me and you're like, I don't get it yet, this would be a great time to pause, ask Mr. Mounts, myself, any questions you have, and continue on. Here's a couple more examples. Try that out. What do you get? Ready? Boom. Do they match? Hot dog. All right, then do the inverse. What do you get? Does it match? Nice. And last but not least, we have the tangent. We can't forget the tangent. Just as important as the sine and the cosine. Again, when are we going to be using these? We're going to be using these the next time Miss Nash is back in class. We're going to be finding out our vectors and our forces, and we're going to be finding opposite sides because we're going to know how to use our SOHCAHTOA. So let's review. You will need to memorize what SOHCAHTOA is: sine, opposite, hypotenuse; cosine, adjacent, hypotenuse; tangent, opposite over adjacent. If you have any questions throughout this video, make sure you pause, play, rewind, ask Mr. Mounts or myself any questions. That's why we are here, people. All right, I would take a time and I would finish assignment number 1 before watching video number 2.